to clear the concept, we'll do that, and then if you have Sai, we'll surely try to make as a summary session.
Okay, sir. Thank you.
Yeah. Okay, Sai.
So one another thing, the Solve with instructor session slides of week 6 is not uploaded in the portal.
Oh, okay.
Yes, sir.
Okay, we'll upload it after this session.
Okay, sir. Thank you.
Good morning,
So,
sir.
just to confirm, is this a doubt session or a recap session?
Can we think as both? Doubt session will be like, first I will take doubts, and if you don't get, like, everybody is silent or don't have any doubts, then we'll recap the contents, whatever in week 7.
Okay, I did have it. Okay, I'll ask in a minute. Okay.
Yeah, sure. What's your doubt? Let me share my screen and we'll take your doubt.
So,
Excuse me, sir. There's a general question I want to ask.
What is that?
So actually, I haven't got good marks in quiz 1, and I was unable to submit many of the assignments, and I want to improve the marks. So, like, I want to like take the subject the subject which I've taken, like English and maths, in the next term. So I want to like leave this term, and I want to like starting from fresh from the next term. So what should I do? Like,
Is that possible to continue in this even?
but sir, I think I can continue, but like it will be not like I will not get the good grades and all, because like due to some time commitment and all, some personal
Okay.
issues, I can't continue with this term. So like I want is to start from the fresh from the next term. So what should I do? Like,
So yeah, you can start from the next term. There is no issue. If you continue it this time, that would be also good. If you have problem to continue, you can do in the next term. There is no issue. You can.
okay, so I would like to like I would have to register in the next term with this subject,
Yeah,
like that.
whatever you are going to take the subjects, you can. Then
So
you have to
what will
register.
be my CC like before it was, or something extra or less CC?
In the first term, like in the first term, this like math, stat, city, all four you can take. According, if
Okay.
you have time, all four. Or otherwise, all four these subjects you can take. Otherwise, if you don't have much time, like what are you working professional or a student?
No, I'm a student.
And you are doing any course from somewhere?
Uh,
Any course?
from May, I will be enrolled in a university.
Anna University. Okay.
No, Anna,
Which
it's a
course?
university.
Which course?
BA Social Science, Ajim Premji University.
Oh, then I think you can take all courses. Otherwise, two courses you can take.
Will I get options for all 4 courses?
Yeah, you will get always.
If you score enough good, then there is specifically written that you can opt for courses. It is
Yeah.
mentioned in your dashboard.
Okay, thank you, sir.
Yeah. So let's start the session.
so can I ask my question?
Yeah, you can ask.
Yeah,
You can ask first, and one by one, please raise your hand. Then we can continue.
lecture 6.2.
6.2.
Can you, yeah,
Okay.
can you speak over there to 9 minutes and 21 seconds?
Okay.
Uh, no, not the lecture. Yeah,
Yeah, this
9
is the
minutes and
lecture
21 seconds.
62, right? 6.2 or 7.2? On the logarithmic or week 7 or week 6? Sorry. Am I audible?
Hello,
You are audible,
Yes, sir,
sir.
you are.
hello.
Yeah, hello. Hi.
Am I audible?
Yeah, you are audible right now. So which lecture? Like is week 6, 6.2 or 7.2? Okay, I think.
Harish, you are not audible.
Okay, Harish is there. Okay. Next, please raise your hand one by one and ask your doubt. If you don't have doubt, we'll start the summary session. Please let me know what's your doubt. Who is come here for just for doubt?
Yeah,
Please. Yeah.
so
Yeah,
sorry,
Harish.
it was my internet issue. Can you seek to 9 minutes and 21 seconds?
On week 6, 6.2 lecture.
Yeah, that's yeah, 21. Yeah. So over here, the first graph that you see, that is for x, and the
Yeah.
second one that you see, it is x plus 1. So it should
Yeah.
move a unit ahead, right? Then why did it move a unit behind?
See, okay, you are asking, okay. So just you can verify, cross verify directly, like till what value of x it will work. So like it will means this one is positive. This x plus 1 would be positive. So for what value of x, this portion x plus 1 will be positive. Behind the this line, right? Till like if you substitute here minus 1 by 2, still you will get positive value. So I directly mean to say this one, right? Like this is log 4 x plus 1 is there. So this portion, this whole portion should be positive. That means x plus 1 is greater than 0. That says x value should be greater than minus 1. That means this x minus, sorry, x is this minus 1, x is equal to minus 1 is going to be asymptote, right? As for general case, x, suppose base is 4. So that means this x should be always positive. In that case, your asymptote is the y-axis, right? X is equal to 0, x line. Similarly, for this case also, your value should be positive. That means x value should be always greater than minus 1. In that case also, that means your x is equal to minus 1 line is going to be asymptote for the that whatever you are saying.
Okay,
For
yeah, got yeah, got it. Thank you.
Okay, the next is Aradhya. Hello, Aradhya.
Sir, I had a doubt in graded assignment sixth.
Graded assignment 6. Okay.
Sixth.
Okay, which question?
So question number 6 and 7.
6 and 7. Okay. For m and n greater than m. Okay. So what's your doubt here?
So how to solve this? Like I tried to plot this graph on Desmos. Afterwards only I was able to solve the question. How to plot this graph manually?
To plot the graph, like for which function? This one? Log.
Yes. Or is it really necessary for this question to plot the graph, or we can solve this without the
Yeah,
graph?
without plotting, see, always it is difficult to plot the graph. So without plotting also you can you can do. So,
How can you
so
explain?
what is the question? The amount, just a minute. The amount of gold in kilograms sold by the jeweler on mth day of 19 given by the function this one. Okay. So if m is greater than, choose the function. Which function value is, like, at which point the function will be greater than? If m is greater than n is greater than that value is greater than 9, in that case, which one will happen? So how did you try this?
I tried to plot the graph on Desmos.
Okay. Without that, how you're solving it? Without
Sir,
plotting, how will solve this?
how I tried to solve this by
Hmm.
changing the base, like I made it like log m plus 1. So made it the first equation like log m plus 1, log 10 to the base m plus 1. And I take half power to the on the other side, like it's the power of 0.001. Then I
Yeah.
proceed to solve.
Yeah. That's one thing. Yeah, you can do. That's the good thing. Like, you can make the change base. You can use the changing base and
After that, I put a log base m plus 1 to some constant variable like k, x, something like that.
yeah. So without plotting, like, how you'll do that? Okay, we'll upload the solution. They will easily get that. Otherwise, we'll quickly just recall. Just recall means we quickly. I will give the hint. So you have function fx. Sorry, is m is here. Fn is equal to log base 10 is m plus 1 minus. This is m plus 1 minus log 1 by 2. Okay. 2 log. I think what is that? M plus 1. And this value is 0, 0, 1. So this one, this is fine. This is make it base as a constant minus what you can do here. Like, this is 1 by 2. This is log m plus 1. So what is this? This is 10 to the power, or we can
Minus 2.
by minus 2. This is 1 by 100. So you
Right,
can
sir.
take, so this is 10 to the power minus 2. And this minus 2 will go here. So this will be 10m plus 1. And this is going to be plus here, minus. And this is log
M
m
plus
plus
1,
1.
10.
Now there is see that there is a symmetricity kind of like in the base and this value. So you can change the base, make as a constant. So finally you can write this one as 1 by log 10m plus 1. Okay. So this is now this is kind of with base, some value is here, and we want to check it for if m is greater than n. In that case, what is going to be the function value is, it is if it is the mean to check here is the function is increasing or decreasing. That's the question here.
Right, sir.
We want to check it, is this function is increasing or decreasing, or yeah, the 4 option is based on this. So now see, if you think is this one as some variable like x, suppose this is x and this is 1 by x. This is the same, assume this one is x, thus this one is going to be 1 by x.
Right, sir.
Now you can think this is a function. Let's say this is just function gx. So can you tell about something? Is this increasing or decreasing? What could you tell about this one?
It's
As
increasing.
when is it increasing? This all value, the values of m and n is greater than 9 is given, and this one is given. So using that, what can you tell about this one? Is this increasing or decreasing? So assume that, say, for any, like assume that m and n greater than is still greater than 10. Using those value, what can you say? Like always you will get the value positive when m and n is greater than 1, sorry, greater
Right,
than
sir.
10, then always you will get positive.
Right,
So
sir.
whatever the function is written here, see, you will get always greater than. If x is, suppose x1 is greater than x2, then gx1 greater than will be greater than gx2.
Gx2.
So that means this function is increasing. So directly you can now tell that is this fm is greater than n or not. Like this you can think. Is this clear?
Yes, sir.
Yes,
Understood.
sir.
Yes, sir.
Okay.
Sir,
Okay.
how I proceed from here? Na, like I took m from like let m is equal to 9. 9, sorry, let m is equal to 11 because and n will be 10. I
Yeah.
proceed like this, then also we get this fm is greater than f of n.
Yeah. That's the one thing. Like assume that I just took general case. So here is, you can think x1 as a 11 and x2 as a 10. Oh,
Yes,
sorry,
sir.
here, not here, here is. You can take, then it will be whatever the value. That
Yes.
means your function is this one, some kind of.
Yes, sir.
Try to make it positive. In the positive case, you can think, because we want to choose, this is MCQ. So only one option we want to check. So this
Right.
is quick thing. Otherwise, you have to, if your solution is given, you have to properly write how this value or why this function is increasing. Okay.
Okay, sir.
Once you will study the calculus, now you are in the week 7 and week 8. So once you study the calculus, very easily you can get this function is increasing or not. Just derivative this function. This is going to be 1 plus 1. This is minus 1 by x square. Derivative of this one. And from here, whatever the values is are getting, like if so in some interval, if gx, suppose in some interval, if gx is always greater than 0, in that case your function is increasing. If gx derivative of the function is less than 0, your function is decreasing. So that's the one thing. Without that we can think it. Okay, and I'm leaving the 7th question for you. I think this is just for this 19 jealous. So let's so amount is asking how much amount in 2019 he have sold. I'm just leaving it for you. Okay, just try once now. I hope how to solve it. Okay. Okay.
Yes, sir.
Because I want to discuss on week 7 more. Graded or practice active I have already done. Once it solution will uploaded, you'll get that idea. Okay. Maria want to ask something.
Sir, I also actually had a doubts in grade assignment 6, but if you want to proceed with week 7, then I'll ask some other.
So which graded question?
Question number 2.
Okay. Okay. This is okay. Suppose 3 distinct person A, B, C are standing. Something is given, and distance between C and A is the same as distance of between C and B. Okay. Okay. The graph is also given here. The coordinates of A, B, and C are okay. Log value is given respectively. What is the distance between?
Maria, mute yourself. There are a lot of background noises from your side.
Oh, sorry.
So, what is the distance between? Let me mute because a different sound is coming. Okay. So some function is given and the coordinates then given as a variable. So you need to find the distance between 2 points. So what's your doubt? Like just use the distance formula and then we'll get that. And it is a net kind of.
Sir, I did it, but I got a different answer actually. I don't know, maybe calculation error.
Then I will say just see the solution probably, but now is the due is over of the graded assignment. So today after 10 or 11, you will get the solution PDF, because you only want to check it as the calculation portion. So that I
Yeah,
will
okay.
leave.
Yeah, okay, sir. Thank you.
Sir, in the same graded assignment, 9th question, sir, just what is the formula to use there, sir, to simplify to find the value of that?
Okay, so here, if it is the same, if this is given, then what value of n should we apply here? So if you, this is here, change base you can use. We can do it 16 here. So here, this what we can do.
So log to the base 3 and log is same.
Yeah, what is that? M to the power log 3 2 plus 2 to the power log this base 3, and the value is m.
Yes, sir.
And some equation is given 16 as this is 16.
Yes, sir,
So,
32 or 60.
so if you have this one, like you can think, see, there is a similarity here. Here is 2, or here is 3, kind of like log 3, base is given 3 and 2 is here. So can you do something more, like, is this
Sir,
fine?
A to the power of log b to the base a is b, sir. That formula have you substituted
A
here?
to the power, sorry,
A
what
to the
is that?
power of log b to the base a is equal to b.
A to the power log base b c. So this could be written as c log same base a. We can write it as, we can write like this also, right?
Yes, sir.
This is
Yes,
A to,
sir.
we can use this formula, because now you can change in this form. This is log,
Okay, sir.
sorry, this is 2 to the power log with 3 same base. This could be written as this one plus again 2 to the power log
M base 3.
this is 60. How we got this one? This is B and C. So you want to, like, is this formula is, are you getting how to get this? This is fine?
No, sir.
No?
No, sir. Because of that, I got this down.
You can, like now here, how we change this one, you can assume, suppose this is Y. Now you can take the log with base A.
Yeah.
Okay. So
Yeah.
this is going to be log both side B,
Yes, sir, log.
C, and this is log A, and this is log AY is going to be. So
Then
this
it become
value,
log base. Yes, sir.
this will become 1. So here is log BC, and this is 1 is equal to log AY. Now both side you can change it, like this one, this could be written as log CB equal to, in the everything is in the itself, like everything is positive in the domain of log. Everything is happening in the domain of log. So you can, whatever you want, you can change it.
Mhm.
This is with base A. Here is, this could be written as both side I have just interchanged. This could be 1 by log CB, and this side is 1 by
Yes, sir.
log YA. So this could be, I just wrote directly here.
Yeah.
In the way, like after doing the cross multiplication. Now they change this log in the now change this to okay. Now you can take here with you want to find the value of y, because we want to equate it.
Yes.
So from here, how we can do this? This could be written as y to the power log CB equal to A. This we got. After doing this we got. Okay, so without doing, if you do here, same e to the power, okay, we'll get the same. So something we have to, okay, so from here now what you can do, y equal to a to the power same we got. Okay, so manipulation we need to do.
That's
Fine.
it for the proof, sir.
We want to base here C to make it as C here. Okay, so you can think this one as, to changing this one, C to the power log A, sorry, this is y, A equal to B. This we can do. Okay.
Yes, sir. Okay, sir.
Now, okay. Something we can do, like this formula is fine. This formula is fine. Some
Yes,
more
sir.
manipulation, like okay, how we do this? We want to make it base. Here is C to the power BA with the same base. Okay, just a minute.
So notes for the 6th week has not been.
This is A to the power, like we are just trying to find the formula exactly. This is B and C. Okay. Now what we can do, this y is equal to, take the log with base 10 both side. 10 just log. This is y is equal to, this is log B C log A. Okay. Now this is log B, sorry, C base 10 upon log base 10 B log base 10 A we can write. Everything is just divided. This formula is right. We can, if
Yes,
A
sir.
is there, B and
Base
C,
change
then we can,
formula.
base change we can do. Like I change the base all on the base 10. This is also base 10. Everything is on base 10.
Right, sir.
Now what we can do, you can shift here. This is C as this side, like this is 10, sorry, A, and this is 10 upon log 10B, and this is log C as it is. Now this could be as base 10. This is log AB and into log with base 10 C. And this is log, okay. Now finally, this is here is log 10 y. Here is, you can again do this. This is log B A log base 10 C. So now again you can remove the log base 10. So again you will get what? Y is equal to directly C to the power, as here, C to the power log B A. As here we did. See, this one we got when you took log with base 10, both sides, you got this one. The same expression we have with the same expression. Or you can think directly, right? This will just take the 10 to the power. 10 to take both sides, 10 to the power. Just take, you can take 10 to the power something. So this is 10 to the power log base 10 y is equal to, this is 10 to the power log BA, and this is log 10 to C. Now this is value exactly y, and this you can think first log, this is y making as 10 This is log base 10. See, because this is in multiplication, so finally you can do like this. Now this is C. So y is equal to C to the power log BA. Is it clear? No, I think I just
Yes, sir, clear.
Is it clear how we got this one? So finally, that's why this expression is true. I just wrote whatever here.
Yes, sir.
Okay, sir. Okay, sir. Okay.
Are you getting?
Yes.
You can.
Yes,
Okay.
sir. I'll practice it again. I'll look it. We'll go further.
Yeah, just watch it again easily. Like easily, you can think. Just what I am doing here. You have this one. Okay.
Yes, sir.
I assume we have y is equal to this. So assume I taking both side with base 10 log. Take both side log with base 10. So this is here. And
Yes,
this
sir.
expression will multiply in the form of here, and this is log 10 you will get. Till here, is
Okay.
it clear?
Yes, sir.
Now, this could be think as now do everything on the base 10. This one is base 10, this one is base 10. So this is, this is this, if you have this kind of thing, suppose you have CB. So if you have this expression, you can write this one as log with the same base B. Changing base formula.
Yes, sir. This I know, sir. Yes.
This is fine. So this I did here, the same thing. Now everything on base 10.
Okay, sir.
So,
Yes.
okay, so this is everything is in multiplication here. So in place of this expression, just write this one asymptote one, and here is the same. Everything is multiplication. Okay. Now from this portion, the same as here you are getting with the same base you break.
Yes, sir.
Everything is
Log
changed on
B.
base 10, so you can back here. So
Yes.
B A and this is log C. Now
Right.
finally you have this one, this expression, log base 10 this. So you can take a to the power everything a to the power. This side also, both side. Taking both side as 10 to the power. 10 to the power everything. So I just took as here. Now this is going to be this same base and to the power here. So this is going to be exactly y. Okay. Now here is in the multiplication, and you know the power formula. If it is a to the power bc, then
Yes,
you
sir.
can write a b c kind of thing. As I did here, so the same thing. Say in the place of so 10 to the power log base 10 c. Okay.
Yes.
And this
Oh,
is
yes.
going to be here. And
Yeah,
finally
yes.
you got this expression. Okay.
Right, sir. Yes.
Okay, using this expression, you can solve now whatever
Now this is simple, sir. These are both
okay.
left hand side. You can simplify and
yeah.
okay.
Pravidya, anyone don't have on week 7? All of you watched on week 7 lecture? Pravidya?
Yes, sir. Morning, sir. So,
Yeah,
one doubt, sir. The question 10 in graded assignment.
on the same graded, okay.
Yes, sir. Just one option. They've given an option called it's a polynomial, sir. So, how is it, sir? Like,
which option?
the third option. The given graph is a graph of a polynomial.
Okay,
it is not a
Huh?
smooth curve. It is not a smooth curve. It is
Choose the correct
breaking.
option.
No, it is not correct, sir.
So why this option is not true, right?
Not true, sir, because
Yes,
it is
sir,
not
sir.
a smooth curve.
Because this is not a smooth, like it is a breaking, no? Here is the you are at many places you are getting as asymptote, and ever you got that for any polynomial, ever is like there is any asymptote, ever you study in the polynomial case, is this happening for a x is equal to 1 is going to be the asymptote. Polynomial is just x to the power any integers, so it is defined for all value of x. So there is no asymptote generally in the polynomial, we'll see. But here is at many places we are getting asymptote. This one as. It is kind of asymptote is saying this is a breaking. It is a break.
Yes,
And
sir.
this
They
line,
will never
whatever-
meet with each other.
Yeah, at x is equal to 3, line x is equal to 3 is going to be the asymptote. As here you can think. Otherwise, there is a break. for any polynomial, you can find the for each value of x, you will get always output. But here is a break in between, like for what between, what is going to be the value? There is
Yes, sir.
nothing.
It's not defined. Okay.
Yeah, it is not defined there.
Yes.
That's the problem. So that's why it is not a graph of a polynomial.
Yes, got it. Sir. Thank you, sir.
Okay, next is Pradeep Kumar. Hello, Pradeep.
Hello, sir. Good
Yeah,
morning.
hi. Good morning.
So, I have a couple of questions. So, just to continue on this question, right? So, I mean, how it says the fifth option is correct. Okay.
1, 2, 3, 4, 5. Okay, this one.
Yeah. So, I mean, the remaining options, I'm kind of have an explanation, but the fifth one, like, I mean, the graph is breaking, right? It's having like kind of asymptote, multiple asymptotes, and also, I mean, how do we come to this equation here?
So see, everything is, if it is in the log, here is written. So inside portion should be greater than 0. Inside portion should be always greater than 0. The 1 plus in this is a multiplication. The whole, this is inside a polynomial.
Okay.
So this is the whole thing is should be positive. That means now you have already the graph here and you have some expression is written. Okay. Now, if you think that your value is like, what do you think for value once you have x is equal to -2? What you will get here?
X equal to -2. Well, it will be log 1, log 10 of
log 1.
Yeah.
So that means -2 is going to be your root. Is this true?
Yeah.
Fine. Yeah. Similarly, -1 is going to be root. If you substitute x is equal to -1. Right. So -1 is again here the root. See that everyone now you can check that every point as here is the root is given. All are the root of 3, 4, 5, 6 also. 3, 4, 5, 6. Everything is in the root.
Okay.
Now you can think that okay, root is fine. Now just take the value in between 1 and 2. Can you take -3/2, or you can take the value between here 3 and 4. Okay. So if you take the value in between 3 and 4, what you will get here? This will give positive. Right. This will give because of 3 is the value in between 3 and 4. Yeah. So that means this is positive, but
this is negative.
Negative. 3 times multiplication of negative.
Yeah, overall it will be negative and less than 1.
And no, need not be. It is greater than greater than -1. Sorry, greater than 1. You will get the final expression as a negative value.
Correct.
So that's why in this portion the function is not defined in between. I just took an example for in between you can take.
Okay.
Similarly, you can check for others. So similarly, you can verify that okay, in between is not defined and okay, roots are fine. And is there anything more? No, the expression is just expression is given. Okay. So again, something more you have to investigate. Once you investigated, like okay, in between is not defined, and which portion in this portion is going to be positive value is positive or not.
Okay, so one more thing I add on to that. So I understand that the equation expression part where we have x and also that will be negative or positive depending on the values. Okay, yeah. So when we make one, say if it is negative for the scenario what we discussed 3.5, so it will be negative. So 1 minus negative will be less than 1. Okay, so that's where that's what I understand now. Within those values, because the expression is, I mean, the graph is breaking, right? So can we define the range as -infinity to +infinity? Because I mean, I don't know what the values in that range, right? So it's more like an asymptote, right, in that region.
Now, if you take the value, once you values are greater than 6, so everything inside is positive, right? This one is positive, fine. And
greater than 6 is okay, sir. I mean, so between 3 to 4.
Between 3 and 4.
Yeah.
So okay. So between 3 and 4, how? So in this portion, your graph is not defined, no? No. I just took one example to so that, okay, in between, if you're taking the value or not
Correct,
getting out.
correct. It is graph is not defined. That is where I was wondering, like, is the range of the given function, could it be minus infinity to plus infinity? Because I mean, I don't know whether it covers that range, right?
Oh,
Okay,
you are
that's
saying, okay, it is going to be, okay. You are saying this one.
Yeah.
Okay. Okay. Oh, you are asking for the range is minus infinity to.
Yeah.
Oh, why this option is in?
Yeah.
So, if you assume that your value is, if you assume that, okay, if you have this expression, so at x is equal to 3, you got 0.
Correct. Yeah.
You got the function value is 0.
Yeah.
Okay, fine. Now, if it is, okay, just a minute. If it is x is equal to 3, you got okay. So, just substitute here what you will get. This whole thing is 0, and this is log. I think I'm missing something.
Log 10 to the base 10 1, that will be 0.
This is 0.
Yeah.
Okay, fine. You got output 0. So what is going to be your asymptote here? When x is you have, okay, let me see. Here is. So if it is coming to when x is approaching, like if x is approaching to -3, suppose for the x is equal to 4, as x is approaching to 4, your output is, okay, this is increasing to 0. Okay. So okay, sorry. So how you are getting the infinitive, like how the range is infinitive? Okay. So what could you think in the case of, okay, let me suppose you have log with whatever the base is here, some 1 plus x plus 1, x plus 2, x minus 3, I think. And once you verify that, okay, sorry, how the range is, okay, so this is showing itself, okay. So once you got that, this is the graph of this is the graph of the function. Without that, see, these are the not stopped. These are just for showing these lines are going to be the asymptote, like in between. That's the meaning here. The whole graph is like this portion is telling you the, like, this value in between, you are getting not defined in between. And these lines are working as a asymptote.
Okay.
That's why the given range is like whatever, as you go to the, like, okay, once you verified that, okay, this is at 3, you are getting value 0, and like greater than 3, take a, okay, yeah, x minus 3, x minus 4, x minus 5, and x minus 6. You have this expression. Okay. Now at x is equal to 3, you got log 10 1 is equal to 0. Now suppose, okay, I think
So it's because an asymptote, we should assume that it covers all the ranges of.
Yeah, that's the reason. That's why I want to tell you that these
Okay.
vertical lines are working as a asymptotes. If
Okay,
at is
okay.
asymptotes is there, then whole values will cover, like minus infinity to
Okay,
infinity.
okay, got it, sir. Okay.
From the graph itself, it is tell you, it's saying.
Okay. Okay, sir. Yeah, got it.
Mhm.
Yeah. So, sir, one more question. I mean, it's a follow up on the one more person asked that question on second one, graded assignment 2.
Mhm.
Okay, so see, we resolved that equation. Okay, I mean, it's a distance one, right? So
Yeah, this is just formula. That's why I'm not
yeah,
solving.
correct. I mean, equating distance to between AB and equating to BC. Okay, I got the expression. So one couple of answers we got: 3x equal to either 3 or 9. It cannot be 3 because it won't work. The log 5 will be less than 1 if we take 3. So 3 of x must be 9. Okay, till then everything is clean. Okay, the only doubt or confusion which I got is like, okay, as per this question, right, it says the distance between A and B is same as distance between C and B.
Yeah.
Okay, so while I'm replacing the expression 3 power x equal to 9 and then started finding the equation, I mean, whatever I do, like I was not getting the value of BC equal to AB. Okay, that's where I was having a lot of confusion. But anyway, since the answer was given as range.
In your range, in the range. That's
right. Since the answer was given in the range, so I mean somehow it worked for me. But otherwise, like I mean, as per this question, like both A and B should have been equal to BC, right? But that did not come out, so that's where I was getting confused. Am I making
so surely you will get value in the log, some log, some value is given in the log. BC maybe, like I'm looking that log value is sorry, the BC value will be distance between point B and C will be log base with base 5 3/2. Some value will be given. So if you use that one like that, if you solve that expression, you will get expression in the, like you will get the value of x, or so the distance between the point B and C in the some log value. So if we exactly substitute the points on as the log value you got, then you exactly will get the, okay, B and C, the distance between B and C and sorry, A and B and B and C, the distance between these 2 points are the same. Not even the range. Like if you substitute some value like 0.34 like this, if you substitute, you will not get exactly equal. But whatever the expression you got, suppose as here, the distance between the point B and C is log with base 5 3/2.
So
if you substitute this,
sir, it will be like, see, if we take only distance between B and C, right, it will be square root of x2 minus x1 the whole square, so which will be nothing but x2 minus x1. Okay, so if I take log 5 3 power x minus 9/4 minus log 5 3 power x minus 9/2, so it will eventually become log 5 3 power x minus 9/4 by 3 power x minus 9/2. Okay, so here 3 power x's answer is 9. So if I resolve this expression, what I get is like a 27 by 2 sorry, 9/2 into 27 into 4/27. So 2 9 3 is 27. So answer we get is 2/3.
3/2.
Log 5 2/3.
Answer you will get 3/2.
No, not this. On the other side, we get.
Yeah, I will upload the solution. Okay, I will upload the solution. Then maybe next session you can ask. Okay.
Okay.
Because this is just for the next session you can ask.
Sure, sir.
I will upload this.
Okay.
Okay. I think I have spent much time on just solving the graded. Let me upload the solution. Then please see before asking the question. Okay, just a minute. Let me upload see the solution. Then back to if you are not getting, we will try to discuss on week 7 because this is for week 7. Okay, just a minute. Okay.
Sir, lecture-wise summary is more efficient way to summarize.
Yeah, that's I want. We just give a minute because I am looking only question on the this graded thing. Let me upload the solution. Okay, now everybody can see the. Okay, just a minute. Now everybody can see the solution of week 6. Now whatever you have doubt, first ask the solution, then ask the doubt. That would be good. Because already.
Yes, sir. We'll go to the week 7, sir.
Yeah, we'll try to discuss week 7 more because we have 1 hour still remain. So
we can clear the doubts in the office hours for week 6, I think, sir.
Yeah. Okay, fine. I hope now my screen is visible. So this is, yeah, let me see if anyone have. So Pravidya, what's your doubt?
So week 7 activity 2, sir.
Okay.
Question 2, 4 and 10.
Which activity?
2, sir.
So when you summarize the 7.2 lecture, then after that you can take, na? It will be easier to understand then.
Okay, just a minute, Pravidya. So which question number, Pravidya?
Question 2, 4 and 10, sir.
Okay, so 2, 4 and 10. Okay, there are 10 questions. Okay. So what's your doubt in second question? Like you have expression is given. Answer, okay. It is just asking for the value of, this is a function, no? So see, I think you have doubt this. So if you have, suppose you have function fx is equal to, let's say, x square plus 2. Okay, some expression is given. So you can do operation on function is, if you see the video, there is one portion written, so you can do the operation. Like suppose you have this one, and suppose gx is equal to some another function, let's say x by 2 is the n. So you can do the operation, or you can get the function even. This means that this is a function. You can do operation on function. So this means that fx plus gx. This is operation on function. So similarly, if it is written as 3x, that means here it would be 3 times the function fx, whatever the expression is here. Okay. So same as here.
Sir. Yes, sir.
If it is 3, f by g is written, just find f by g. That means, say this is could be done. So f by g x, this means that fx upon gx. And if it is 3 multiplied here, 3 by 2, or I think 3. So that means This is multiplied with 3. Now you can get the value, just substitute value 2 and you can easily get. Is it clear? Pravidya?
Yes, sir. So the next one also, sir, f of g and cross 0 is like,
Yeah, it is the
just
same on.
multiply and
We have multiply, just multiply and substitute the value.
We have to
Okay.
place 0 in the place of x.
Okay.
Yes, sir.
Okay.
The 10th question also.
10th question is there. Okay. So if you have function this one, so it is asking for the composition. As just now you did. Composition, just this is f of x. In place of, as here the function in place of x, just substitute, because this is the composition of itself. So in place of x, just substitute x by upon x plus a in place of x. Now solve the expression and equate with this one, and you will get an equation in a. And solve that, you will get the value of it.
Yes,
Or
sir.
even after comparing the numerator and denominator, you will get the value of it. Okay. This is a composition with the itself function.
Yes, sir. Got it, sir. So also activity 4, sir.
Okay. Limit of a sequence.
First question, sir.
First question.
Yes, sir.
Okay. So then I will say, once I will summarize this, you will get that. So, okay, this is the definition itself written of a sequence. What do you mean by a sequence? Sequence is nothing but a function. Okay, let me tell you. Let me, from the sequence itself, let me start. Because before that, I hope it is on the graph and
Sure,
tangent.
sir.
That
Like,
is a
please
separate
go
thing.
ahead
And
with the summary and I'll get back to this, sir. Sure,
yeah,
sir. Thank you, sir.
because I am leaving the first two lecture, as the first two lecture is just recalling, and everything is not tough. Like, there is no concept. The one variable is just using the variable. The first topic is just recalling the whatever you have a function. Like, I am just leaving the first lecture and the second lecture. From third lecture, let me start. And the limit of sequence and limit of a function, that would be good, because these three lectures have the concept. The first is just recall of different kind of function. We'll quickly do that otherwise. The recall of the function in the first lecture is that asking like what kind of function you have till before the you have studied, like quadratic function, which is the degree, which is a polynomial itself, which have degree 2. Linear function. Linear function is means it will the degree, it will be a polynomial which have degree 1. So like this, or 3x plus 2. These are linear function, a function which is a polynomial and it have degree 1. That those functions are called linear function. Quadratic means it have degree 2. And trigonometric functions are there. In the second lecture, I think trigonometric, talking about the trigonometric function. Okay, trigonometric function. So there is sine function, sine, cos. So what are these? These are nothing. Already it is, if you see in the video lecture, I hope if you studied that something in the 9th and trigonometry,
Yes, sir.
best thing is like, what are these functions are there? These are the periodic function. What are the property means? These are the periodic function. And how this function we got? See, it is come from the like right angle triangle.
P by H, B by H, and all.
Yeah.
P by B.
If you suppose this is a right angled angle, this is 90, and suppose this is A, B, and C is here. So directly from here you can infer that sine, this suppose this angle is theta. So sine theta is this one height and this hypotenuse, I think. Yeah, this is BC and AC. I will tell you in the variable also. And cos theta is exactly base and this hypotenuse. This is AB and this is AC. There are three main important trigonometric equations: sine, cos, and tan. Tan is exactly sine theta upon cos theta. This is. So if you substitute here, sine is B by C, sorry, BC and AC upon this is AB and AC. So in both the whatever you have, you can cancel out in the denominator, and this will be BC upon AB. BC upon AB. This one you will get. So see, this is theta is here given. So as this one is also, here is a variable, but this variable written, see, if you have an angle, this in a degree form, you can change a degree in the radian, or even itself, this you can think as a degree. Why we need to change, like an angle is written as the radian and degree, there are two things. So I think this, if you have a value in a degree, you can do this by 2 pi upon 360. While you're adding this value, you can change this degree to radian. Is it clear? I'm saying, sorry, is it correct, right?
Yes, sir.
So if you have, suppose you have a 90 degree, suppose this angle is not 90, suppose this angle is given 60 degree, theta is equal to 60. So this is in degree format. So you want to change this in this radian. So why? So the first question, why we are changing in the radian? The reason is, see, if you have, suppose you have a line, suppose you have here. Okay, suppose you are here, and if you want to measure the angles like this, so you have the maximum degree is, you can think like 360. After 360, you will start repeating. But still it is correct. Like you can do many times this one. But this is repeating the same angle. This is 360. Then after 360, and again, if you repeat it again 360, it will become 720. But still, you are unable to, like, if you are here, you did one round, okay, again one round, the same, you will get here the same at the same place. So why we want to change this degree in the radian? Reason is that because this is a periodically it is happening the same at the same position you are getting. So can we do in the real line? Can we do it in the real line? This degree can be changed on the real line, because on the real line you will get different value. Because of that, we needed a radian. So you can think, or whatever you have on the value on real line, those values are in the radian. Like if you have suppose 3/2, if you are thinking it as a angle, some angle, so you can think this is written as in a radian. So if you want to change in this in degree form, so you have to multiply. So this is in radian. Radian is in hidden. You can think as pi. You can cross multiply and directly. I think this is 180, and this is going to be 540 degree. So you want to, like, a degree thing, we want to change in the real number. This is a convention. This is a, like, I don't know how made this kind of, but we usually do in the mathematics that, okay, if you have a degree, you can change in the radian to get the real values. So whatever the values are written in this here, this is kind of radian it is written. Okay, in the sine value give itself, like you want to get the value of, suppose you have x, so you can do it in the, you can change it in the radian. So after multiplying 360 by pi, you will get in degree value. Suppose you got the degree value. So there are some values, if you see in 10th class, in the book, the values are written sine, cos, and tan. Not even sine, tan, not only the sine, cos value is written. And inverse value of the sine cos also written. So there are some value like sine 0. Value of sine 0 degree is 0. Sine degree of 30 degrees, I think 1/2. Sine value of 45 degrees 1 upon root 2. And sine degree of 60, sine value of 60 degrees root 3/2. Sine value of 90 degrees 1. Cos value of 0 is 1. Cos value of 30 degrees, I think root 3/2. cos, no, sorry, 3, sorry.
It is just a trigonometric table, right, sir?
It is, if you see in the, you can just watch any book of 10th, I think.
Yes, sir. It is
trigonometry.
in 10th book, sir. NCERT 10th book.
So this is 1 upon root 2, and this is, suppose cos 60 value will be 1 by 2 and cos 90 value will be 0. And tan value, tan theta will be directly sin theta upon cos theta I will get for all value. So, and there are three main thing. Now, if you have, suppose you have a function, okay, you already know there is a inverse thing. So see, sine cos is a periodic function, but still in some interval we can make it 1, 1. So let me tell you the graph of sine function. So sine function is periodic, okay, 0 to 360 as here, as we see that, right? If you are here 0 to 360, you will get, after 360 you will get repeated. It is started repeating. Okay.
Yes,
so
sir.
But we want to, like, in some interval we can sine function we can make as a 1, 1 function, because it will not a periodic, you will get a fixed value. So to making a fixed value, if you think that minus 1 by 2 to 1 by 2, sorry, this is, sorry, pi by 2 to minus pi by 2, in this interval. So let me draw the graph of function. So sorry, sine function. So at, suppose this is written in the degree format, if you think that, or in the radian. So at 0, you have 0 value. If you have changed the all value in the radian, so this all value change in the radian. Okay? 0 will be 0 degree will be and 0 radian. This could be written in the radian. Everything is written in the radian format. So if you have this one at 0 value, sine value is 0, and the graph of sine function is like this. So at, suppose this is pi by 2 here at 90. Pi by 2 means 90 degree. So at 90 degree, you will get 1 value. So sine values always you will get between the minus 1 and 1. And at minus pi by 2, you will get the minus. At minus pi by 2, it will give the minus 1. So in this portion, actually the sine function is 1, 1. So there is a inverse function now called sine inverse. So in this function, in this portion, you can invert the function in the interval minus pi by 2 to pi by 2. Similarly, you can think for others. For the better explanation, just read out the book. I'm just giving a very small, like these are, you can tell something about the sine function. So there is, after getting the sine function, there is sec and cosec is there also, and cot also. So sec this sec is actually 1 by cos. Sec theta is actually exactly 1 by cos theta, and cosec is actually, cosec theta is exactly 1 upon sin theta, and cot theta is exactly 1 upon tan theta. So there are some function and there are some property, like if you have a sine square theta plus cos square theta, this is equal to 1. Some other sine 2 theta is equal to
2 sin theta
into cos theta. These are just formula you have to remember for trigonometric function. Once you remember these all, that's enough to solve the problem. And this all theta is actually, you can think here in the radian or degree, that's not matter. Everything will be written in the question. If it is in, everything is meter in degree, surely it will be written. If it is written in the radian format, surely. Generally, what happen if the sin x is given? So usually we think that this is written in the radian format, in the real line, on the real line we usually think it. So whatever you have, suppose you have fx is equal to some sin x plus cos x is written. So here is x is as written as the radian. and directly you can think, then that's why you are able to draw the graph, or we can think we can do, because this we change in the radian and we can think the graph of the function on the real line now. That's why whenever x is written, it is as directly assume that the value are written as the in radian format. Usually if it is not in radian, then surely it should be mentioned, otherwise something should be surely given that you are thinking in a radian or degree. But in the both cases, it will not much effect on the question. If you are thinking in the degree, or if you are thinking in radian, it will not affect much on the question. Easily
Like-
can be understood while solving the question.
Like while we are using the log and the ln, how it was very similar, we should be getting the same type of answer for radians and degrees.
Yeah, if you suppose your function is log, suppose fx is equal to log sin x is written. So here is, we need still see this portion is needed is greater than 0. So you can, so here is actually you can think in the real, in the radian. That's why you are able to draw the graph of the function easily to draw. So here it is, if it is not written, it is in degree or it is in radian. So just assume that this is in the radian format in the real line. Now you can think, now for it is assuming those value of x. If you talk about the domain of this function, so it will assume those value of x which give the sign value is positive. So in this portion, minus pi by 2, sorry. In this portion, you will assume the value of x. Means value of x is always greater than 0 to pi by 2. Or not pi by 2, in this portion still it will work.
0 to pi. Yes.
So 0 to pi, because in this portion you will get the positive value. So in this portion you can think. So for the better thing, just remember the graph also. It will make the easier and to make the understand that the graph of sine is periodic. This means that your function value is repeating. It is between the graph of the like function value of sine, like sine value is in between the -1 and 1. For the cos is there, it will give at 0 you are getting the 1 value. Okay, like this, the for the cos value, sorry, cos function is there. For the cos function, the graph, it is very similar to the sine, but at 0 the sine is 0, but at 0 the cos is 1. Again, similarly, this cos function is also periodic, and it usually give the value between, it is the value between 1 and -1. So you have to think always, like if it is not mentioned, assume these values are written in the radian, and you have to take the domain. This is done because of the thinking on the real line. That's all about. And whatever the formulas or something is written, just remember those formula. That's enough to do that all. And whenever you are solving problem, just remember that the sine graph and cos graph, tan graph also. These three graph is remember always, and easily you can do for the trigonometric question. In this course, there is not much on the trigonometric. Generally, you will see that it is not, you will not see more question on trigonometric directly on the polynomial, quadratic. But it's enough to deal with these functions are the usual function, not not a difficult thing. It have some property. Just remember those property. That's enough to solve the problem. So this is all about the trigonometric function. Let's move on to the sequence. What is sequence? Is it clear whatever I told you? I don't know.
Clear, sir.
Yes, sir, clear.
Okay. So no need to worry because of the trigonometric function. Just remember some formulas. And if you are very much confusing with how the x is there, just think that this is in radian. That's all. It is in radian, and remember the graph of the function on the this graph is on real line. So remember the graph of the function on the real line of the sine, cos, and tan. That's a to deal. In which portion it is positive, in which portion it is negative. What is the range of sine and cos? It is in between -1 and 1. Those are that's all.
To convert between radians and degrees, there is some equation. So 180 degrees is equal to pi radian something. How do
Sorry.
we to convert between degrees and radians, sir.
Just multiply with pi and 360 degree. This will give a value in the radian. If you have degree, just change in this. They will give whatever the value after solving. Suppose you have 30 degree. Okay. Okay. I want to change in the radian. So pi into 360. So this is, I think, will give, this is 0, 0, and this is
Pi
12.
by 12.
So pi by 12 you will get. This is in radian. 30 degrees is exactly equal to pi by 12. Okay, this is
90 degrees is equal to pi radians, pi by 12.
Pi by 12. So on real line, so pi have some value, right? Pi have some 3 point something is there.
yes, sir.
1 4 something is there. So okay, that's the meaning. You can directly 3 point. So this is 3 point something upon 12 on real line. On you can think. Suppose here is going to be the pi upon 12. So you came on real line now. Degree you can change in radian now on the real line. That's the process you will use to apply.
Sir, can you tell us the important formulas of trigonometric function which can be used in this course?
Okay, so whatever the values I just wrote, those are the important. Like this one is like sine cos. That's the enough.
Yes, sir.
These
are just values.
And another thing is you can for majorly it is this one, sine square plus cos square x is 1, and sine 2x is going to be 2 sine x into cos x. And for the cos also you can think cos 2x is equal to cos square x minus sine square x, or 1 minus 2 1 minus 2 sine. From here you can think that what is going to be here. From here you can generate. So the main thing is here, very important, this one and this one also. In place of like this is sine A. If you have sine theta plus alpha, so this could be written as sine theta into cos alpha plus cos theta into sine alpha.
Yes, sir. It is sine A plus B formula, right?
Sine A plus B formula.
Yes, sir.
So just one thing, you can directly search on Google. Okay.
Okay.
The main formula is generally this one. Just directly search on the Google that trigonometric formulas. There are many formulas. Not all need to remember. Surely, see in the question, if it is trigonometric function, and surely if you see that in hint, the formula should be written surely, whatever the formula is going to use.
Okay, sir.
So don't worry with that. If it is some formula is given, surely in the question itself, you can say that some formula should be written there. Surely it will be written.
Okay, sir.
Okay. So don't worry that this trigonometric. Okay, let's back to this sequence. Sequencing. What is sequence? So sequence is whatever in the 10 12 I think you have studied that sequence is that many times I have seen, like when I was the interview of TA's selection. So there, whenever I used to ask the sequence, they generally say this one, like any series, like this is kind of like, suppose 1 3 5 7, like this, like they used to say this is a sequence. That's fine. This is a sequence. But if you think about what are these are what, like it is written in the kind of this one. So what are these? Can you think these are in a like a function? So sequence is nothing but a function. Sequence is nothing but a function. So let me write that here. This is 3 5 7. So can you think what is this sequence? Can you think this is as a function? What is this sequence? This is let's say fn is equal to 2n minus 1.
Right,
where
sir.
n is natural number. For suppose we are natural number for because in the this is maths 2. So in maths 2, natural number came for started for 1. So assume that for natural number you have started from 1. For the time being, I will again back to the 0 thing. Okay, for this time, assume that your n is 1. So now see this is a kind of writing the terms here, but this is actually a give, like if you substitute 1 is n is equal to 1, then you will get 1. F2 you will get 3. F3 you will get 5, right? F4 you will get 7. So see that what is happening here. You are substituting values from the natural number. So sequence is nothing but a function whose domain is fixed, natural number, and range is any real number. That's the sequence. That's the definition of a sequence. That's all. So whatever you studied in the 12, that is also a sequence, but behind that now you are in the BSc thing, no? So you need to be do more analysis. So in the more analysis, this whatever the terms written in this fashion or whatever something is whatever in the 12 I have not I didn't
arithmetic
remember.
progression and geometric progression. Yes, sir.
So those all are a kind of can think as a function.
It is
So
also
these
a
are
sequence.
so those are a function, in the function where the domain of the function is natural number. As you see that whatever the sequence you used to write, that is suppose 1, 5, 8, 10, 7. So this is kind of you used to write that is a sequence. So for n is equal to 1, so now let's back to our 0 thing here, because I am not substituting 0 because it will give minus. So
Yes,
still
sir.
it work for this one I just wrote. So let me add here -1, then it will work for 0 also. Okay. So sequence natural number is started from 0. So this is a sequence. For 1, then you will get for 1 you will get 0 if you substitute. Fine. So if you substitute 0, then you will get -1. If you substitute 1, it will give 1. Yeah. So this is fine. So for this is a sequence, and function in the function form it is written in this fashion. Now if you think this one, if you are assuming this is a sequence, so it's still fine. So for n is equal to 0, your output is 1. For n is equal to your 1. So sequence is nothing but a function. So you can think this is a function. This is a function where the output is written here. Input is, it is automated that n is equal to 1. This is 5. This is 5. N is equal to 2. Automatically it is inferring that. Yeah, for n is equal to 2, you'll get 8. N is equal to 3, you got 10. So making a pattern now here it is difficult in the function in the kind of expression it is now difficult, but it is inferring that this is a function. It has some function. It has some expression where you are substituting as n is equal to 0, you are getting output. N is equal to 1, 5. N is equal to 2, 8. So sequence, whatever you studied in 12, the same thing is there. Only here is your sequence is here in the function expression generally denotes in this term. Like sequence are generally in this term you are studied as a kind of function. That's why many people used to get the confusion that whatever you studied in 12 that is different or here is different. No, the same thing is here. There you just studied on the output, but now you are in BSc. So here is mean to say you are doing more analysis on sequence. Here is the written Rudrans is written as sequence is a controlled order of arrangement. So if you see that it is arrangement of the in the if you see in the 10 12, it is like if it is suppose 1 and 3 and suddenly -1 and suddenly 0 and then you wrote 5. So in that case you are unable to deduce that how you will get the arithmetic mean or how you will get the geometric mean. In that case it is a difficult, but but whatever 10, 12 you studied, like it is an increasing order. It is always whatever you study, it is kind of increasing order. It is a kind of in decreasing order, or it is a multiplying up to increasing sequences kind of. Those all you studied and used to get the arithmetic mean, geometric mean, harmonic something mean is there. Harmonic mean. So those are on the based on when you have sequence in the increasing, or some have some order. But now here it is not necessary. You are studying in more detail. Sorry.
Yeah, so just I'm telling you, like the sequence should be in a fixed pattern or a rule, like.
It is in a fixed pattern. And whatever you studied in 12, whatever you studied, that is on 12. Now, can we generalize that? So whenever we started to generalize, we generally think on a function, because function can be function. You have some machine, you are giving some input, you are getting some output. So the general form of the sequence, now here you can think that is a function. In that case, so there you used to same thing is happening, like for n is equal to n is equal to 0, you are getting some output. So this is a progression is written, and here for input you are getting the output is only written in this fashion. But if you want to do something more, then you can think, we have to think some in kind of function. So the same sequence is there, but only the broader thing. So broader thing is you are thinking on a function, and the function domain is fixed, that okay, the domain is natural number. So your input is the same thing. So let me write now with an example. Suppose you have a sequence fn is equal to, let's say, 3n plus n square. Okay, so here is, this is n, not x. So this is n. Now this is a sequence. So if you write in the progression form, how you'll write? So n is equal to 0, just n is equal to 0, you will get here 0.
0.
For n equal to 1, you will get 4. For n is equal to 2, you will get
6, 10.
10. Like this you will get. So see that this is also a progression. It is happening in order. So for n is equal to, see in behind, if you see in the function case, so suppose I just wrote this progression. Okay, something is there. Forget about this all. Now you'll say that okay, this is a sequence, but behind it is happening that this function, this sequence, whatever the progression is there, you can think as a function. So finally the function is, suppose somebody says this outputs you got from this function. So this is n is equal to 0, and n is equal to 1, n is equal to 2, n is equal to 3 values are written. So this is a sequence in that case. So sequence is nothing but a function where the domain of the function is natural number. Okay.
Okay, sir. So the domain is fixed, and the output we get is the sequence. We fix the domain, and then what we get is on the real line.
It could be real line, or some part of, or some interval, or maybe some integer. Output is not fixed, but input is fixed. Input is natural, all is natural number.
Okay, sir.
But output is not fixed. It could be some interval in some portion, or you will get positive 0 to infinity, or integer kind of thing.
Sir. Okay, sir.
So the question is, why now when we doing the broader, like whatever you 10, 12 studied, now we are doing something more on the same thing. We change those sequence in the function now. So why we need this function? What is the use of this? Why we are restricting this sequence? What is use of this one? The main thing is why this we need it. So simply see, whenever
we have to estimate the output.
Estimating, or estimating is one thing. See, suppose now you are a function. Suppose you have a function fx is equal to, let's say I'm just writing a polynomial, that, or let me write in the fraction form. Let's say x minus 3 upon x plus 1. Suppose you have a function. Okay, and see, this is for any real number it is defined except x is equal to minus 1. In place only for x minus 1, everything is fine. For any input you will get output. So we want to study something more about this function. So how will you study? So what you used to do, generally you think on this is a real line, and what you used to do, you can substitute n equal x is equal to 1, x is equal to 2, or x is equal to -1, x is equal to -2, and something try to infer that, okay, I'm getting this one, so maybe the function, the graph will be like this. Or whenever you started the graph of function, always used to substitute the values some integer, positive integer, or you can in different word I will say some natural number. Means on the natural number you try to put here and try to get that, okay, the graph or the points will be output as here. Like this you can estimate, as we human being used to do. So what we are doing, we are actually doing on a sequence. Now you can change this function as a sequence. Actually you are doing on a sequence. Whatever you are substituting here, no, 1 2 3 0 1 2, and estimating, okay, graph will be like this or maybe like this. So actually we are doing on a sequence. So that's the use of here sequence. Means if you want to do or you want to estimate the function or something, want to do more on a function, anyhow we have to back on some portion. Like this is on whole real number, but we have to reduce this function in the some integer in the natural number. So reduced, see, this function is defined on whole r minus 1 except this one. So see that this is a domain. So can we make a part of a domain? Like can we think on x is on the natural number? See, this natural number is a subset of this domain. So first study on the subset, okay, on this natural number. First study this function on the natural number, on the subset, and slightly we can move ahead to the whole domain. See, whenever will do on more mathematics thing, no. So whenever we want to study something, suppose you want to study on a whole world, something want to do on the, so in the like something you want to do some on a, you want to study, suppose you have in this space the want to study, or in a jungle you want to study the whole thing about a jungle. So what you will do, in some portion you will started studying, and slowly you will try make it out and study, right? This is the process human being used to do, right?
Yes, sir. We
In some
increase the
portion, in the you will break the whole that jungle, that woodland, whatever you will say, that jungle in the some portion, then started study on a subset. Okay, the same thing is happening. You want to study on whole real number, so just break on the natural number, full study on the natural number, then go ahead. The same thing is happening. So as here you have a function, you want to study more on detail on this function, so just break on, just study this function on a sequence. So the from function you can back to the sequence. So as this one, this is a sequence, you are studying on a sequence, your input is now here, the same thing as you said, substitute 1 2 3 and estimate to the graph. The same thing is happening, substitute here 1, so you will get 1 minus 3 upon 1 plus 1. So this is minus 2 upon 2, this is minus 1. So here you will get at input 1 you will get -1. So here, so trying to estimate, the same thing is happening here. So that's use of sequence. This is the use of sequence. Okay.
So I can say that sequence is the series of functions.
Not series of functions, no. Sequence is the some like you are getting the output in the discrete format.
Okay, sir.
You are getting the output in the discrete format.
Yes, sir.
Now you are studying on the some small portion. Suppose this is the whole real line. Now you are studying on the natural
numbers.
And once you studied on thoroughly on the natural number, then go
we
out
will
on
increase the area of study.
Area of study.
Okay, sir.
That's the one thing. Now see, once you know the sequence, there is terms came limit of a sequence. Why we needed this limit? What do you mean by the limit of a sequence? So suppose, let me write to here. Suppose I have now, all of you know very much what is a sequence now. I'm just generally writing, suppose you have a sequence fn is equal to 1 upon n plus 1. Okay. So suppose you have a sequence, this one. So what is going to be the output here? For 0, it is going to be 1. For 1, it is going to be 1 by 2. Okay. For 3, it is going to be
1 by 4.
1 by 4. For okay, 2 is
1 by
for
3.
2, it is 1 by 3. So this is output. This is the output.
Yes, sir.
So can we like these are the output is happening. So suppose I want to write value for n is equal to 1000. Okay. So what is going to be the value here? 1 upon
1000.
1001. Okay. This is
Right.
going to be. So suppose I am now substituting very large number, which I don't know, but I want to say that, okay, suppose n is equal to some very large value. Suppose 000. I don't know what is that, but I just said for very large value, I want to try to get the output. Means, can we estimate the output now? Like, when I am substituting very large value of n, can we estimate the output? Is this lie -1? It is very close to it will be close to -1, or it will be close to output will be close to 0, or output close to 1. I'm trying to estimate because I don't know what is going to be the very large value, but can we estimate that the whatever the output you will get, it will be close to -1, or it will be close to 0? Close to means it will be very near value to 0, or it will value you will get, it will be very near to 0, or it will be very near to 1. That's the meaning. Here the near word is actually the limit. Just change the word near with the limit. Estimating with that thing. Like when you substitute very large value, see that it will give
infinity.
Not infinity. It is what we will get. Will very large value. That
Very
means you are
small
very
value.
close to 0, very small.
Yes, sir.
Okay.
Very small you will get, no? As here. This is 1 upon very large value. Large number.
So limit determines that how close we are to a some number.
Some number. That's the one. That near means that limit.
Okay, sir. Okay, sir.
That's the limit here. So here is you are getting output whenever I don't know what is very large number, but here substituting, but I want to estimate. So estimate means here we are coming very close to 0 means. So whenever you are getting input very large number, your value is decreasing, started decreasing, and it is tested, and it is reached to the very close to 0, very near to 0. You estimated the output as, you can directly say, whenever we substitute very large value, the function value will be close to 0. That's the meaning.
Okay, sir. So I say if I put n is equal to 1 lakh, then it will be less. It will be far than if I put n is equal to 1 crore. It will 1 crore will be more.
You will say that it will
so
in the rough word you will say it will be very near to very small number. It will be very near to 0.
Okay, sir.
In the different word you will say, in the rough word you will say that the rough word is actually limit.
Okay, sir.
That rough word is actually limit. That near value, estimated value in different word.
The maximum input value we are deciding, no, sir?
Maximum input. So yeah, then you can see that now you can mathematically say that limit as n goes to infinity means you are going to very large. You can give the input very large to this function. That's the meaning here. So can we say something that, okay, always it will be like, I don't know. Now, as here I'm saying, I don't know what I am substituting here, but I'm saying very large number. So here it means that you are substituting very large number. You are going to give the input very large number. So here is you are estimating very large number. You are giving input as a very large number. So can we estimate the output where it will be go? It will be close to 1. It will be close to 0, or it will be close to -1. So that's the here limit. When you are going to input very large number, what is going to be the output? So that estimated number I want, that's the limit here. So what is here? For this case, your estimated number is 0. You will directly say when you are substituting, this is the rough meaning, rough word you will say, you are substituting very large number for the input. You are giving the input as very large number and you are getting the output. So what is going to be output? I am unable to tell you what is that bigger number, but yeah, I can say that number is going to close to 0. So that this is the estimated, this is the rough number, and this is the limit actually in different word.
So like you can say this number is very small, but a positive number, like very small,
but positive number, very small. So very small, that number is going to very small. But so in the rough way, so why we are using, what is the use of this one? Why we are saying? So suppose whenever you are unable to get the exactly output, no, so we see, so how we see, whenever you are climbing on a tree, so how you used to try to climb on a tree in some small portion, and like you want to climb on here. So what you will think that if I will reach to here, then I will directly get that this one. If you are started to climb on, you will in starting will think anyhow if I will reach here, then it is very close to this and then I will reach here. So that's here the same thing is happening. Here is estimating the, suppose I am giving the input very large number, what is going to be output? So can we think that very near to something, give the thing that okay, just estimate that. Here is we are estimating no to reach here. So here this is the estimated thing. Directly you will say, you will say that I reached here, then you will say okay, now I'm here, because there is one step just want to climb. That's the meaning here. That's the same thing is, you just said okay, I got the input output 0. So you will say that okay, I got, whenever we substitute very large number, it will be close to 0. In your word, in rough word, you will directly say this.
Okay, sir, because the distance is so minimum that we can touch this point.
Yeah, that point, that's the use. That's the limit. So see, this is the analysis called of mathematical, the calculus analysis or mathematical analysis when you study the mathematics in. So see what we are studying. We break the function in the small portion. Now we are trying to estimate something. So actually what is happening? So let me differently write here. So what is going to be the limit of this function, this sequence? Now you have this sequence fn is equal to n minus 3 upon n plus 1. So what is going to be limit? So limit means here is n is always right. Input is natural number. So for n is equal to 1, it is going to give. So what is going to when you substitute very large number? So here is what the estimated value you will get when you substitute very large number. So that means what is going to the limit of the sequence of this one? What is going to be the limit of this sequence? So how we will solve this? If you have some idea. No? So you can think now this one as, you have this one, okay? Just try to manipulate or rearrange or break some function in some small portion so that you are able to do that. If you substitute here very large number and very large number here, then what output? This one is also very large number, this one is also very large number, and you will not reach on a conclusion. But we want to reach a conclusion. So how we'll reach that? So just break this sequence in the some portion like n upon n plus 1 minus 3 upon n plus 1. Right? This you will get. Now what you can think? You can take n both sides count from here. So n, so this is n upon n, this is 1 plus 1 by n minus 3 upon n plus 1. Now you can cancel out n from both sides. Here is n is going to be very large. That means n is not 0. So you can cancel out from both sides. For the always you are assuming you are substituting very large number here. For each time you are doing all. Just fix that and think that okay, for the 10 lakh I am doing all this expression. But in the mind you can think. Okay, but do on the for n. So think that this is a very large number and doing these all for the very large number. So this is going to be 1 plus 1 by n minus 3 upon n plus 1. Or you can think this one as 3 into 1 upon n plus 1. Now, what is going to be here? This is, as just now said, now when you are substituting very large number n, your estimated value that this is going to be 0. So directly say that, okay, when you are trying to get, so this will substitute, when you substitute very large number, it will close to 0. So close to 0 into 3 multiply still will give the close to 0. Now think for here, this is 1 upon 1 plus 1 by n. So this portion is again the same thing as happening. It will give the very close to 0. Okay. This will go to 0. Okay. This 1 plus will go to 0. The same thing. If you are adding, suppose something is very close to 0. Okay. And you added that. So it will give the whole thing will go to 1. And 1 upon whole thing going to 1, that means this is going to be the same as going, the whole thing is going to be 1. And this is here 1 minus 0 kind of thing. So this is going to be 1.
So can you just repeat it again?
Okay. So you have this one. Okay, you finally got 1 plus 1 by 1 here.
1 by n, right? Minus 3 upon n plus
1. Or
1.
you can write this one as 3 into 1 upon n plus 1. Okay.
Yes, sir.
Okay, now assume that you are doing all these things for a very large number, or you can think that already I have seen many of you have convention that, or many of you know that, okay, 1 upon infinity is 0. Generally, people used to think. Why? Because they used to think that this is 1 upon infinity means then generally people used to think that this is 1 upon 0.
It is
this is not true.
undefined.
This is not true, but people used to think that infinity means 1 upon 0. So what they used to do, this is going to be 1 upon infinity means 1 upon 1 by 0, and they do multiply here and directly say this is 0. But this is not mathematically true, but yeah, you can say in the rough, in your mind, this is true. In your mind, if you are thinking, that's fine, but this is not mathematically true. This infinity is not a number. This is not a number. This is undefined.
Okay,
but
sir.
Student used to think this is 1 by 0 and do this all. It means it is a very, this means it is a very large number. So how will sign the very large number? This is the sign for, this is the main infinity. Now, whatever you are doing here, so here is, assume always you are doing all this for very, very large number value of n. Okay, so it will give, so 1 by very large number will give it will give very close to 0.
Yes, sir.
Value will output very close to 0. And again, if it is 1 plus 1 by n, it will, what we will get? Very large number. This will 0 and this is added each time 1. That means it is going to be 1. That's the meaning here. And 1 upon 1 plus y1. So this whole thing is going to be 1. So now you can think that this is going to be
1. Yes, sir. Because 1 upon 1 plus 0 gives 1 by 1 and it gives 1.
Yes. So you are doing all this for very large number. That's why it is happening. So assume that this is very small. Now you can very small. Now you can think that this is 0. So everything do on the assume to be not exactly 0. It is close to 0. Always say it is close to 0. 1 plus very close to 0 number will still give the very close to 1. That's the meaning here, right? If you are
Right,
added
sir.
very close to 0 number added with 1, it will give the very close to 1. So that means here is close to 1.
So it
divided with the same, it will be close to 1. So the whole thing is going to be, now we can, in the sign case, here is going to means, see this sign is, the arrow tells you are getting, you are going to, you are estimating your value. This is the estimation. This is the limit in different word also you can say. So this, the whole terms goes to 1 or limit 1. The whole thing is 3 into very large, very small number. This is very small number. 3 into very small number still will give a very small number. Very, very small number. We are multiplying with 3, still will give to 0. This is going to be 0. 3 into 0 will give 0. The same thing, the whole term is going to be 0. Now here is 1 minus 0.
It gives 1.
1.
So the value is always lie in between -1 to 1, right, sir? Because the large number we get, it is going to be more close to 0.
Value of?
Because the large number we get, it is always going close to 0.
Not necessary. No, for the 1 by n is always think that. So now you can remember that for any case n plus 1 or 1 by n, or for 1 by n plus 2, or any case as n goes to infinity, this limit is goes to 0.
0. Okay.
For each cases.
Because we don't know
here,
how long the number is.
How big number you are dividing with by 1.
Okay. Okay, sir.
Okay. So this is the mean of limit. So you have this sequence now directly. So this limit is 1 now. We finally reach to the limit of. So limit of this sequence is 1. So I just said here for the what is the mean of, well, like how, so what is use of, why we are studying the sequence. Okay. Okay, this is all about now. See, this is for n is always here is n goes to infinity. You are doing all for very large number. But suppose you have a function now, the same limit concept. Suppose you have function x. Okay, this is x minus 3 upon x plus 1. Okay, same limit concept. Can you think that the same limit word, can we see this case for natural number? Now we can extend the portion. Can we think the same limit concept on a real number? So here mean to say, there we used to say like here for n plus 1, n goes to infinity, you are getting 0.
0.
This is the case here. Now always you know that for, because your input is natural number, so for large number you used to think. But can you think here for any general, now this is on a real number. So what is going to be the limit when x is going to be here? Now here is x. What is going to be limit when x is going to, let's say 2, I am saying. For sequence, always you will find limit for n goes to infinity. For the real function, you cannot write like this. N goes to here for the sequence case. This is not true. N goes to 2. What do you mean by this? N is, yeah, that's fine here. That means you just substitute here 2. There is no mean to say, because 2 is fixed here. For this number, you will get 1 by 3. When you substitute n is equal to 2.
Yes.
So this is not correct for the sequence, but this is correct for the when you come to the real number, because see here is you are doing work on a discrete, but here now you want a real number. So suppose here is 0, here is 1. So on the natural number, here is the discrete thing on 1, 2, 3 you are doing. There is no mean, like here is no, like this is happening. And this is the natural number, you can say. Okay, but sir, on real line, here is a continuity, no? So you can think on the x going to 2 here. So what is, when you are approaching to 2, what is going to be output here? Your output here.
It will become -1 by 3.
It will close to some number. So can you give that number? It will be close to that number. That's the limit here. So that means in the limit case, you can directly substitute here x minus 2. Here is going to be 2 minus 3 upon 2 plus
-1 by 3.
-1 by 3 used to do this. Okay. Now I'm changing fx is equal to, let's say, x plus 1 upon x square minus 1. This is I have function. Now what is going to be the limit when x goes to 1?
Undefined.
No, so here you have to do manipulation. No, something you have to do, as we did there. So this is not always just substitute that, get that, okay.
Okay.
No, you have to do the something more. Like what you can do here, this is x plus 1. This could be changed as
X plus 1, x minus 1.
Now you can cancel out. Your function is now here, x plus 1. Now limit you can apply. Now you can substitute here. X is equal to 1.
Sir, after just cancelling x plus 1, we get x minus 1, no? 1 upon x minus 1.
Okay, so let me change it here. Minus 1. Now think about this one, for this one.
Yes, sir. Now it
For
will.
this one. Now
Yes.
change for this function, x minus 1 upon x square plus 1.
So we just expand the formula and we get 1 upon x plus 1.
1 upon x plus 1, and now substitute here. As x goes to infinity, your output is going to be close to
1
so
by
here
2.
the mean to
Half.
whenever you are your input. Now in the graph, just think that suppose here is 1, here is 2. So you are we don't know, we are unable to draw the graph of the function, but one thing we know that what we know, whenever we are very close to 1, the output will suppose here is 1 by 2. So output is very close to 1 by 2. So here somewhere output you will get.
Okay. It is just an estimate that we are approximately here.
Here the
near.
approximated. So limit is actually the approximated value, not exact value.
Okay,
Approximated value. When we are approaching here we are approaching from both sides. We can approach here from both sides. From negative side means here some smaller value. Here mean to say here, let me tell you now. Here is x approaching to 1. What it means that? It means here is suppose is 1. So from this side, from bigger to smaller to 1, we can approach, or from a smaller less than value to 1 to close to 1. There are two ways we can approach, right? Here is happening this one. This means this one. We are approaching to 1 from both sides.
So while solving questions, we have to take care that we just don't directly put the given value in the equation. We just try to expand the formulas as you did in this example. And as you say, limit is the nearest value, not the exact value. We have to also see that.
Yes, limit is not an exact value. Limit is actually approximated, nearest, rough value.
And when we are dealing with natural numbers, we can fix the input here. But in real line, we can't fix the input, right, sir?
Yes. For the natural number, for the sequence case, input is actually doing on very large number you are getting. No, but for the real case, the limit is actually your some fixed value, because here is the problem. Here, when you why are trying to get this limit here? When you apply directly on this function, we are getting infinite, like we undefined number. When you are substituted s equal to 1, it is giving undefined number, but we want a estimated value of, like when we are substituting when we are very close to 1 here, what is going to be the output? It is some fixed number, or still it is undefined. So actually that means it is going to be some fixed number 1 by 2. So see the graph. Let's see the graph. While looking the graph, it is very clear to you. Desmos. We have x minus 1 upon x square minus 1. See that where is 1? I think, let me make it bigger. 1. Here is minus, where is 1 by 2? Here is 1 by 2. So if you see that here for this graph, when you substituted 1, it is so that's
it
the
crosses the 1.55.
Yeah, it crosses. Here is the value. See that It is, see, for directly you are substituting here, it is kind of undefined you are getting. But see the graph here, what is happening? It is continuously showing.
Yes, sir.
Why? The reason is you are, whenever you are giving the input, the output is actually very close to where is
0.5. It
0.5.
is
0.5. See that. So that's the meaning here is happening. We are unable to, while looking, you can say the function is not defined there. But when you draw the graph, how you will draw the graph? Because you are able to draw graph for very close to 1, right? Because for the very close to 1 value, still the value is defined. Only at 1 it is not defined. But from very close to 1 it is defined. So still we are able to draw the graph, right? So that's the
Yes, sir.
process here. At 1 it is giving. So at 1 the value is not, here is, if you make it bigger, still it will show, because the real line is kind of, it is a
It is
rubber.
a
How
full
much
of
you stretch?
numbers.
Full of number. How much you stretch, still it will stretch.
Yes, sir.
That's why,
As we got in week 1, if we get two irrational numbers, we can find many irrational numbers in between
yes.
them.
So because of this clustered thing, very close to thing, you are unable to see the break,
Yes,
but
sir.
actually it is kind of happening. So there is not break. You are so there is a break actually, but here the thing is like it is the around this one, you are getting the output very close to 1/2. That's the here happening.
Yes, sir.
This is the mean. That's the limit here.
Okay, sir.
So limit is actually also used to help to drawing the graph.
So there is also a graph in the reflection of it. It is when we put -1.
In the -1, okay.
There is also a graph in the
When you
reverse order.
substitute here -1, yeah, so the same cases will happen, because here you when you substitute here -1, you will get 1. Again, the case is for undefined. The same very similar case will happen for the positive and negative portion in this portion and this portion.
So the undefined part,
sorry?
Undefined part, like there are 6 or 7 indeterminate form where we use limit all along, I think. So, sir, how many indeterminate form we have to learn for this course? Like,
so generally, why we studied these limits? Yeah, why we studied, whenever, see, at 1 we are unable to get the value, but we want to estimate the function at very close to 1. In those cases, we study the limit. So in different way, why we needed this limit? Why we are studying this one? So the case is here, for 1, we are unable to estimate the function, but at exactly 1, we are unable to tell the value of the function. But can we estimate? Can we give the rough value of the function? So that's the process here to get that. Okay, if you are very close to 1, we are getting the rough value of the function, or simply say around the 1/2 will get the value of around, if you are around the 1, you are getting output around the 1/2.
Yeah. So like every time whatever form we are getting, the method of solving each question according to so the form, the indeterminate form, according to the indeterminate form, there are some techniques or there are some methods to solve questions.
Many times, always, like you can rearrange, you can manipulate terms, or in the next week you will see the indeterminate form there to find the limit. So there are some tools. So this is the process to find the limit. So actually this is the process. There is no other method. Something we have, like, okay, if you have some limit values, you have to remember that, okay, like sin x upon x.
Yeah, is one.
Limit as x goes to 0. What is going to be the output? So it is kind of indeterminate form also. It is actually going to 1.
Yes.
It is going to 1. When you study the indeterminate form, directly you can derivate the numerator and denominator, that it is going to be cos x and it is going to be 1. And now substitute x is equal to 0, you will get 1.
Yes.
So always you will get tools. Something tools surely will be given, and using those tools you can find the limit. So mathematics is the only thing, right? You have some tools, and from the tools you have to infer.
Yes.
So this is the process to find the limit. And what do you mean by the limit? I hope all of you get what do you mean by the limit.
Yes, sir.
In the same, so value is the same case for limit and sorry, sequence and the function. Function of limit of a function, limit of a sequence. The same meaning of the limit word. You are estimating, you are roughly giving the idea where the output you are getting. That's the limit. And that's all the week 7. And the process to finding the limit is this all. In the next week, if I think Subhasis will take there, you could ask a doubt on how to solving. I hope all you get the idea what do you mean by the limit word.
Yes, sir.
Is it clear to all of you?
Yes, sir.
Yes, sir. It
Yes,
is
sir.
very clear. I just
Okay.
have, because I just don't have math in 12th, I just have to practice more. But it is clear whatever you are try to explain.
So this is all about the I in this week. The main concept is I have seen from the whatever the terms is going on. The what do you mean by limit? Many of you don't know what is limit. So this is the limit. Limit is estimated, approximated, rough, whatever the word you will use, that is the limit. That is the
We should
limit.
have solved one example from the practice assignment, sir, on limits. If you can solve any simple problem on from the practice assignment or somewhere, actually, how to
Okay.
solve the limits with some formula or something.
Okay, in the suppose you have in the graph now I hope you see the in the graph also, like see that this one. Now we have the graph of a function. We don't know what is the graph. It is the shifted form of the sign actually. Okay. Okay. So, but here what is happening? The limit of a function as x tends to 0. Okay. Now see that x tends to 0. What is your output you are getting? Can you tell me? What output you are getting? So
0.
directly now 0. So that means here is this one is wrong. This option is wrong. This option is going to be true. Similarly for
because it
okay,
is touches the x-axis, right? Because
touches the here is the output. This lines are giving the output. This curve is the output, and this is the line input.
Right, sir. Right.
It is touching the y-axis.
Yeah, tangent is actually we'll see in the next. I think next tangent is nothing but we'll see that tangent is actually
touching
just
the
touches
curve.
Touching the curve.
But why they are saying unique tangent? So tangent itself should be unique. So specifically,
yeah. So the simply means to in the tangent. Let me give the idea that the case is for this one. See, the tangent is suppose this is a road. Okay, a road. This is a road. Okay, and you are riding a bike here. Okay. So now continuously you are going. Suppose you are reaches here. Okay. So suppose there is a turn, right? There is a turn. So your bike will try to go ahead directly like this, but anyhow you manage and back to this one. So this is actually whatever you are getting that line directly to go to straight. That is actually at the ending point of the curve. Now the curve is now this side. So at that point is actually this line is going to be your tangent. That is the tangent that touches at a single point and you are getting that straight thing. That is a tangent. Tangent is always a line, tangent line, that's the mean here. Now the same is suppose here. This is a curve. Suppose this is a very sharp corner here. Okay. You are riding a bike on a road and road is kind of sharp corner. So you will try to like you are riding, suppose direct here when you reaches here, it is very sharp corner is here. Your bike will like this one. But anyhow you manage it and move on this. Suppose somebody is on this side and riding on this way. Okay, he is also having the same. At the single point you are getting two different things which touches the curve, and in this case you will not say at this point there is no tangent. There is no that's the difference in unique tangent and here we are getting two different line which touches at the very soft corner. In this case, there is no tangent.
So it means that in a sharp corners, we can draw two tangents. That's why it is not unique tangent, right?
So don't word the tangent thing. You are getting two different line. Two different tangent is actually the direction. Here is the same thing. I said direction. You are getting at this point. You are getting not
Two
only two,
lines.
many direction, many direction.
Okay.
So tangent is actually a direction. Here you are getting many direction at the single point. But here you are getting a single, like unique direction. If you draw the very careful, if you see at this point, it is unable to, like we are unable to see, but actually it is happening the same line. If you go by this way, it will, when you reaches at that point, it will see that the same line will happen. But for this point, it will many direction it is happening. And if you are in that case, then you will say that at that point tangent is not exist. So saying to be the two tangent, just say two direction you are getting. Because when so you uses the word tangent means you are saying the tangent word. So in place of tangent word, if there are two direction is happening, just say at this point tangent is not exist. That is the tangent.
Sir. In the first graph, if the motorcycle driver is driving in the opposite direction, then also it is going in the other direction.
Yeah, it is happening like this. The same in this is the line.
Yes, sir.
But on the same line it is happening.
Oh, okay.
If a motorcycle is ride, this will get like this line, the same line you will get.
The line is not changing.
Not changing, but here it is, you see that when it is going this line, this is another line and this is another line.
Right.
This is the case here.
There are many directions here, and it is only on the same direction, moving on the same direction.
Yes. So this is the tangent thing.
Okay, sir. Okay.
Hope is it clear to all of you?
Yes, sir.
Okay. Now, suppose this is for sequence. Many questions on sequence. Okay, this is also this is now this is a step function. Can you okay? So now once you studied the limit thing, so still we don't have much time. Otherwise, I will tell you the now the left limit and right limit. Now I hope there is another word, left limit and right limit. So I hope the limit is clear. Left limit is nothing but very quickly we can say that there is nothing. Once you very much clear with the limit thing, so left and right limit is very much clear with the step function. So suppose your function, graph of function is this one. Okay. Suppose this is the here and on the same value, suppose here you are getting output here and here is just beside of that line. Started from there. On the same point, there is a jump. And at this point, you are getting output. But after onward, you directly jump to here. That's the step function. So here is, you can say, make a circle. So left limit means you are approaching to this side. You suppose this is A, and suppose this is A, suppose this is B. So when you are approaching to this point, let's say this is alpha. When you are approaching from the left to this alpha, your output is actually A. So this is called left limit of the function. When you approaches from the right to alpha, you see that this is a jump here. So you are getting output B. So this is the right limit. So this is two differences here. From the left, as I said, right, you are approaching for one from the left and the right. So there are two routes from the left and right. So for when you are approaching to from this left, something you got value A. So this is the left limit, and that is the estimated value. And from right, you are getting different values. That is the right limit. Is it clear? Means estimated value.
Okay,
no?
sir. Okay, sir.
No.
Little bit clear.
Yeah. Please see when you will the next session try to ask on the left and right limit. Then Subhas is going to take that, I hope, and he'll tell you very much clearly that what is left and right limit.
Okay.
Slowly see that. Okay. So because why this left and right limits came for the step function. So this is the floor and ceiling function is kind of a step function. Jump, there is a jump. Once you reach a particular point, there is jump. So there is no question on the limit of function. If this is on the step function, that's why I'm not. I just directly. That's why I started telling you the limit. Or we can do this question for the final thing. Quickly we'll
Yes, sir, this
rewrite.
one, sir. The fifth question.
Fifth question is, see, here is also, see, this one is needed some more thing. See, it is in the, here is, see, once you, now hope now watch the session now, like lectures now. Please watch the lectures now. There is one formula in that if it is, suppose you have a sequence an. Now an means your function. Suppose you have a sequence an, fn, whatever the notation. Generally, a sequence is denoted in the curly bracket and a suffix n. So that I just wrote fn, right? So you can think at this is fn. This is a sequence. Notation of the sequence is standard form, you can see. This one. So suppose you have a sequence an and which have limit b. So that means as n goes to infinity, the sequence goes to, let's say, sorry, limit as a. So when you are approaching very large number, the estimated value is a. So that's the here. So suppose you have a sequence which have limit a, okay. So then if you have a function fx or function, not function, what is that? Here is, okay. So here is the composition thing is actually happening. So if you watch the lecture, what is happening if you have a fixed limit a, this is a real number. Suppose let's say I'm giving, suppose fx is equal to, let's say fx is equal to x square. Let's say I'm saying this. Okay, suppose they have, this is a sequence. Now, can you think that what is going to be the sequence f of an? This is directly just term, hope all of you know the composition thing, no? So in place of that x, you directly substitute. A sequence is a function, directly substitute here the sequence itself. Now this is a sequence. Actually, you see that this is a sequence. Fn is equal to actually an square. An is actually some term. An, let's say an is equal to, let's say 1 by n. This is a sequence. Limit is 0. So see that what is happening. So this is going to be 1 by n square. So Fn is now changed. That function now when you composed with the sequence, we got a 1 by n square sequence. Now what is going to be the limit of this sequence? So see that limit of this one is 0. So if you want to find the composition, whatever the composed function you got after limit, just do the square of the limit. So I have this one a, limit as a, so do the square. So sequence, limit of sequence a is actually a square. Sorry, fn. So as here your sequence is 1 by n, so limit is 0. So finally your sequence, when you composed with the function, okay, you got that 1 by n square. So see, this is directly you can find, otherwise you don't have, just say that, okay, this is the limit. So if you are able to write the expression, fine. Otherwise, directly say that limit is 0. So a square, limit of this function is going to be, this sequence is going to be 0. Here is the same thing is happening. Here the limit thing is given. See that limit, here is an sequence is 1 upon n factorial by n, where the limit is given e. Okay, you have some bigger expression. So what is going to be the limit? The same thing, see that this is actually the same expression. In place of n, it is just shifted 2n plus 1. So the actually what is happening, the whole thing is give the same limit e, and this is also e. No, this is, yeah, this is also give the same limit. If you watch the lecture, while telling the lecture, it will be very much clear that how it is happening. This e will give 2e. So see the Before to go now, I will tell you that please watch the lecture, then it will be more clear to you. Okay.
Okay, sir.
This is 2 here is given. Okay. This should be. Oh, this is on log. That's why I'm thinking. Okay, this is on log. So log value of E is actually 1. No, this is ln. Oh, so that's why I think this is ln here. So yeah, this is actually what is happening if you have a sequence an which is goes to a. So log of an is actually goes to log of a directly. There are some more formulas. Okay.
So these
See,
formulas were told in lectures.
it is in the lecture. So please
Okay.
watch those lectures now. You'll get very much clear.
Okay, sir.
So that's for today's session. Hope it is informative for
Yes, it
to
is,
all
sir.
of you. Thank you so much.
Thank you, sir.
Thank
Yeah.
you, sir.
Thank you.
Is the session still running?